Hello, my name's Gary Pace. I'm a professional engineer in CWI out of Katy, Texas. This is Intro to AWS D1.1. This is going to be part one of maybe 5 or 6 hopeful episodes describing and touching on AWS D1.1, the structural steel welding code. Acknowledgements. I took this PowerPoint presentation from the Nuclear Regulatory Commission, Introduction to Welding Technology and Codes course. If you want the bulk of these slides, it's ML12157A587. So if you type in some combination of Nuclear Regulatory Commission and that ML12157A587, this should come up. I also rated the Can Teach Public Domain Educational and Reference Library on Can Do Technology. They've got some stuff in there. It's the nuclear people up in Canada. There's their webpage, and then I also snagged a bunch of stuff from the U.S. Army TM 9 237 Welding Theory and Application. The American Welding Society, when we say AWS, is the American Welding Society. They're the organization that publishes AWS D1.1, which is the structural welding code. It publishes numerous documents covering welding and welding-related activities. AWS produces codes, specifications, recommended practices, classifications, methods, and guides related to welding. So the general subject areas are definitions, symbols, filler materials, qualifications and testing, weld processes, welding applications, and safety. Basically, in North America, the American Welding Society is it as far as an organization that, well, they cover all the structural stuff. The American Society of Mechanical Engineers does anything under pressure. And then there's the API, the petroleum guys that do pipelines and whatnot. But for what we're talking about, if we use the term AWS, it's the American Welding Society. It's pretty much the subject matter experts on welding in North America. And a lot of these guys will do structural, and the guys that write the codes will do both structural and pressure vessel, because there's a lot of overlap there. But as far as we're talking about, AWS is American Welding Society. The overview of AWS D1.1, the structural code, first we got to look at what's in it. So clause 1 is general requirements. That just lays out the groundwork of what's covered by this code. Clause 2 is design of welded connections. I haven't dabbled very much in that. That's generally where the structural guys will go. The guys designing it, the engineers designing the component, dabble more in design of welded connections. I probably haven't been in there 3 times in 20 years. Clause 3 is pre-qualification of WPSs. That's where we pre-qualify WPSs. There's a lot of materials. There's a whole list of materials that have been welded so many times with certain specific filler materials that the American Society or American Welding Society just said, all right, this is pre-qualified. If you do this, 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 and this, you don't have to qualify a procedure. You follow these rules, you can pre-qualify it. Then you've got qualification. So qualification covers anything that you can't pre-qualify, and it covers the qualification of people. Clause 5 is fabrication. This is the rules you're supposed to follow when you're making stuff. After it's been designed and you've qualified your procedures, now we're going to fabricate whatever components that need to be fabricated to supply to the customer. So these are the rules that we follow. Clause 6 is inspection. This holds all the rules for inspecting the parts that we just fabricated. Clause 7 is stud welding. Studs are generally on components if you're going to need to hang something, or the more probable situation is a stud that's for concrete, so you could tie a structure, a steel structure, and then you could pour a concrete deck on it or something like that. Strengthening and repair of existing structures is clause 8. And then they've kind of changed things from previous years. I think the way that the code was written, everything was too messy with tubular structures in with everything else. So they added a clause 9 with tubular structure. Then we've got annexes, mandatory A through J. These are um, parts of the code that really didn't fit in with anything else, so they put them in the annexes. And then annexes K through V are informative. And then there's commentary, which kind of gives you the authors, the people that wrote the code. It gives you their version of how things should go. And then you've got an index. Clause 1 is general requirements. It's the basic information on the scope and limitations of the code. The limitations, it's not intended to be used for materials with a yield stress over 100 KSI. Thicknesses less than an eighth of an inch. Thicknesses of less than an eighth of an inch are a different code. That's D1.1 structural sheet steel, and then there's another code you can use for sheet metal. Pressure vessels, pressure piping, bridges, not part of this code. Base metals other than carbon or low alloy steels. If you're going to use stainless steel or aluminum or titanium, you can't use this code. The definitions, all the definitions that are referenced in this, they go back to AWS 3.0. It's the book on definitions. All the weld symbols, they all conform to AWS 2.4. AWS has a book on weld symbols. This one lays out the engineers, contractors, and inspectors' responsibility. It tells you who's who and how much power they have and what their jobs are specifically, what they can and can't do. And it also has safety references, standard units, and measurements and references. So clause 1 basically sets the tone for the rest of the code, but it tells you, okay, this is what it's for. I've had instances in the past where I had to explain to an engineer that they wanted something built to AWS D1.1 like a hydraulic cylinder, and I'm like, hydraulic cylinders don't fall under AWS D1. Well, it's the welding code. No, it's a welding code for structural steel. That's it. Structural steel, buildings. It doesn't work for bridges. It doesn't work for aluminum. It doesn't work for sheet metal. It doesn't work for titanium. It doesn't work for things under pressure. It is structural, buildings, pretty much it. Anything structural. So you need to understand the definitions and what the confines of AWS D1.1 are. It's the rules for a sport, like football, American football. You can't be playing rugby or cricket with the rules to American football. It just doesn't work. Clause 2, design of welded connections. This clause covers requirements for design of welded connections. It is divided into 3 parts as follows. Part A, common requirements for design of welded connections, non-tubular and tubular members. Part B is the specific requirements for design of non-tubular connections, statically or cyclically loaded. Part C is the specific requirements for design of non-tubular connections, cyclically loaded. So, like I said, I haven't dabbled in this section very much. I haven't done much design. I've been mostly the welder qualification side, inspection, and that kind of stuff. But if you're into the design section of it, this is where you're going to go. From where I read, there used to be another part in this, part D, and then that got moved into tubular. There's a clause 9 now that's just consists of nothing but the requirements for tubular, welding and design of tubular connections and components that are tubular in nature as opposed to the other structural members. Prequalification of WPSs, Clause 3. Prequalification of WPSs shall be defined as exempt from the WPS qualification testing required in Clause 4. All pre-qualified WPSs shall be written. In order for a WPS to be pre-qualified, conformance with all the applicable requirements of Clause 3 shall be required. So what's that telling us? It's telling us that if you dig through Clause 3, there's certain welding processes that you can use. There's certain welding filler materials you can use, and there's certain base materials that you can use. It's kind of like a mix and match with Legos, maybe. You can use this filler material with this base metal and this welding process, And if you follow everything else that is written in clause 3, all the requirements, it's pre-qualified. You don't have to qualify the welding procedure. It's just pre-qualified. So if it falls outside of that, then you have to use clause 4, and you actually have to do a PQR and a WPS for that particular weld procedure. So for welding processes, we can use stick welding, shielded metal arc welding. We can use submerged arc welding. We can use flux core arc welding. And we can use gas metal arc welding. Except gas metal arc welding short circuiting, because we've got different modes of transfer in gas metal arc welding, and the lowest energy form of gas metal arc welding is the short circuiting. Basically anything below about 21 volts is considered short circuiting. Anything above that, 21 to 25 plus or minus, is globular, and then anything above 25 is spray. But you can't use GMAW, gas metal arc welding, short circuiting, and have it be a pre-qualified procedure. You can qualify it and use gas metal arc welding short circuit, but it can't be pre-qualified. Flux core arc welding and gas metal arc welding have some power supply restrictions on it. Code approved processes such as electroslag, electrogas, gas metal arc welding, short circuiting, and gas tungsten arc welding all must be qualified in accordance with Section 4. You can still use those processes, electroslag, electrogas, gas metal arc welding, short circuiting, and TIG, or gas tungsten arc welding. You can still use those processes, but you can't use a pre-qualified procedure. You just have to go bite the bullet and go qualify that procedure. Like I said before, a pre-qualified WPS is a WPS that does not need a supporting PQR. Not required. You've used all the right materials that are listed in Clause 3. The filler material, you've used the correct process, let's say flux core. You've used the correct flux core material, filler material, and you're welding to one of the pre-qualified base materials like A36 or some kind of low carbon steel that's listed on the table in Clause 3. Pre-qualified welding procedure specifications use known variables that have a long history of making sound welds and require no testing. A written weld procedure is required for all pre-qualified WPSs. So even if you're using materials off of that list, you still have to write it down. You have to have a written procedure. You can't just say, oh, it's pre-qualified, I'm using this and this, I don't need a written procedure. No, you need to write it down so that the welder has something to work off of. And AWS allows the use of pre-qualified because there's been so many welds made over the years with certain low carbon steels, and let's say E7018 or E6010, that if you follow these rules, you're probably not going to make a mistake or have something bad go wrong with the weld that you're making for that particular structural component. We've done this for 60 years. We know that if you weld material A with filler material B, that this is going to be the outcome, and it's probably going to be successful. So that's why AWS allows the use of pre-qualified WPSs if you use Clause 3 to qualify the WPSs. Clause 4, qualification. So Clause 4 is broken down into 4, sub-clauses. So you've got general, which is Part A. Part B is welding procedure specifications. Part C is performance qualification, and Part D is requirements for CVN testing. So the general requirements just lay out, a lot of the terminology and the do's and don'ts of utilizing this particular clause for qualification of WPSs. It's the general requirements. Part B is for if you're going to use materials that you couldn't pre-qualify using Clause 3, then you're going to use Part B to qualify the welding procedure. It gives you the rules to operate by to qualify the welding procedure. Part C is performance qualification. Performance qualification is what you need to do to qualify welders, your people qualifications. A lot of people out there get Part B and Part C confused. They get welding procedure qualifications mixed up with people qualifications, welder qualifications. Two totally different categories, two totally different sports, however you want to classify it in your mind. Part B and Part C are totally different animals. And then Part D is the requirements for CVN testing, impact testing. What do you need to do if you're making a structure and it's going somewhere where it's very cold and there's going to be impact? So Part D covers impact testing. But Clause 4 is for use with anything you can't pre-qualify. Okay, so while we're talking about qualification in Clause 4, I'm going to kind of go off into the weeds here, get off on a sidetrack, and talk about PQRs and supporting WPSs. So if you have a WPS and a PQR is not a one-to-one relationship. You can have one PQR supporting one WPS. A PQR is a document that it's like the test run. We welded material A to material B, and we used a certain filler material. We did some bend testing. We did some tensile testing. We showed that we could achieve the desired mechanical properties for our welding procedure, and we wrote it down. We included our lab data and everything else. And that's our PQR, our procedure qualification record. And then we go and write a WPS, which is like a recipe. It's the recipe for cookies or rice or stir fried rice or whatever, bread. That's the recipe we give to the welders, the cooks, and then they follow that. They don't need to know, the welder should never ever look at a PQR. They should only look at a WPS. So a PQR is the document we have back in our filing system, and we show it to the inspectors or whoever might want to look at it to see that our WPS is supported by a legitimate PQR. So a WPS is a recipe for the welders. The PQR is a document that supports the WPS. And as I said before, a WPS to a PQR is not a one-to-one relationship. Sometimes you might have 3 PQRs supporting one WPS. Let's say I started off with A36 carbon steel base material, and I welded it with E7018 low hydrogen electrode, and that was my original WPS. Well, let's say a customer comes along and says, we like your WPS, but we need you to have some documentation for impact testing. So then we go do another PQR with the same materials, and we send it to the lab, and we get impact testing done. So we add that, but that's a different PQR. And then let's say they want us to do let's say there's a third variable that they want us to test, corrosion resistance or something. So we write a third PQR to help support our WPS. So a lot of times you might have a WPS that's got multiple PQRs supporting it. PQRs to WPSs is not a one-to-one. It's just PQRs are a supporting document to help you be able to write a recipe that the welders can use. The WPS is the recipe, the instructions that the welder follows to make a component, follows when he's doing fabrication. So just keep that in mind. PQR supports the WPS. I can have one PQR supporting multiple WPSs. I used to work at a place where I had, there was probably 20 different WPSs that were just all slightly different, and it was for all welding carbon steel and using E7018, low hydrogen electrode. But you'd have a client come in and say, I want it to weld between this voltage and this voltage, and I want my WPS to have this cleaning method and this cleaning method. I don't want you to be able to use a grinding wheel on it. I want it, use this special wire brush from Lithuania or whatever. It was some kind of requirement. So we would have a very specific WPS for that client and that client only. And it was all supported by a PQR from yesteryear. The PQR, the essential variables on that PQR had not changed. So, client A might have a WPS, client B might have a WPS, and client C might have a WPS. It's all supported by the same essential variables on that PQR. Maybe the client wanted a non-essential variable changed because they had a very specific requirement, or that's just how they wanted it written. So this is something to keep in mind. I know I'm kind of getting off into the philosophy of writing WPSs and managing a welding program, but this is something to keep in mind when you're dealing with WPSs and PQ. WPS / PQRs versus personnel qualification. So I stole this, didn't steal it, got it with permission from Walt Spurko. He's the head of ASME Section 9, the code committee, and he's been doing it for years. But he says there's a wall between people and procedures. So the thing is, a lot of people get confused between welder qualifications and procedure qualifications. And you need to realize there's a wall between the two. You don't mix and match. These things do not mix and match at all. The welder qualifications is its own separate sport, like playing cricket or baseball. And then the procedures for qualifying welding procedure specifications and PQRs, that's a different rule book, like playing rugby or an American football. You do not mix these two sports. There's a little overlap with a couple of the terminology, but don't mix and match people and procedure qualifications. Welder qualifications and WPSs and PQRs, they live in two different sides of the wall. You need to respect the wall and not crisscross things. So especially when you're reading about qualifying weld procedures, make sure you're reading in the section that the portion of the code that talks about procedures, and you're not reading about welder qualifications, and vice versa, because it can get confusing and you can make yourself a mess. So respect the wall and make sure you know where you're at in the code when you're doing qualification of welders or procedures. Clause 5, fabrication. This one covers the requirements for fabrication and erection of welded assemblies and structures produced by any process acceptable under AWS D11. It contains 30 sections, which covers all kinds of topics: base metals, welding consumables, preheat, arc strikes, backing gas, preparation of base metals, repairs, all kinds of different subject topics that are related to fabrication of structural steel are covered in Clause 5. So it's a pretty healthy clause and kind of a backbone clause to this code, obviously, fabrication. But keep that in mind when you're digging through here. We'll get into this later. I'll do a little deeper dive into the fabrication in Clause 5. Clause 6 is inspection. This contains all the requirements for the inspector's qualifications and responsibilities, acceptance criteria for discontinuities, and procedures for NDT. Part A is the general requirements. Part B is the contractor responsibilities. Part C is acceptance criteria. Part D is the NDT procedures. Part E is radiographic testing. Part F is ultrasonic testing of groove welds. Part G is other examination methods. I haven't dealt with this clause of the code very often because I'm not an NDE inspector. I've dabbled with it, gone in there a couple of times, mostly just into the visual section because I'm a CWI. I've had to use the visual section, but For organizations that are doing in-depth non-destructive testing of the welds, this is the acceptance criteria, the NDE procedures, and all the information that is required for an NDT, non-destructive testing organization, to be able to do the testing in accordance with the code. Clause 7 is stud welding. Clause 7 contains the general requirements for welding of steel studs to steel, which stipulates specific requirements for the mechanical properties and material of steel studs and requirements for qualification of stud bases, application qualification, operator qualification, pre-production testing and workmanship, stud welding during production, fabrication, erection, and inspection, and then for the stud manufacturer's certification of stud base weldability. Clause 7 is almost like a mini code within the regular code because stud welding is such a different process, but it is so integral to structural component manufacturing that it has to be in here. So stud welding is a different, it's its own little world within a world, if that makes any sense. So it's got different procedure qualifications, how to qualify people, the whole 9 yards. It's just different. So, and that's because it's a completely different process, which I'll cover in the next couple of slides. For those of you that aren't familiar with stud welding, you use a gun. It's like a little pistol. And you take a stud, which is basically like a nail, a big, bulky nail. And you're going to run a bunch of electricity through it. And it's going to go down and touch the base material. It's going to draw back just a little bit, create an arc. The end of the stud is going to get liquid. And at that point, a timer is going to go off in the gun. And it's going to jam that stud with the melted end into the weld pool. And you're going to have this stud, basically a nail, an attachment that is welded. It's fused onto the base material. A lot of times it's like a steel girder or an I-beam that you're going to use to pour concrete on. It'll be some kind of deck, like a floor. So this is what a welding gun looks like, a stud weld gun. Stud welding sequence. The gun is properly positioned. Notice you've got a stud. The stud is in the chuck. You've got a ferrule, which is a little piece of ceramic. Think about a coffee cup or something. It's just ceramic. It holds the liquid weld metal in place. It's like a little mold. So you touch that down, you pull the trigger, and the stud lifts off the work. We're on step 2 there. And an arc is created and melts the stud and the base metal, the parent metal. After arcing is complete, the main spring plunges the stud into the molten pool of metal. So you're just you've struck an arc, you've melted the end of the stud and some of the base material. Now there's a little timer goes off and there's a spring and it just jams that stud into the liquid metal that was created from your arc. The gun is withdrawn. You take the gun off from the welded stud. You break off the little ceramic ferrule, and then you do your inspection. Usually inspection includes like whacking it with a hammer. If you hit it with a hammer and it makes a dong, your stud is good. But if it makes like this, I can't imitate the sound, but if it makes kind of a rattling sound, you didn't make the weld correctly. If it kind of sounds like a tuning fork, you know what a tuning fork is, where you kind of hit that thing to tune an instrument. If it kind of makes that sound, you've done the weld correctly. Here's some stud welds. The top picture, you can see what the weld looks like after the stud has been made. This is a high production process, by the way, if I didn't mention it. You can set up and do hundreds of these welds pretty quickly. Whereas if you had to weld these all by hand, it would take you a significant amount of time to make all of those welds. So you can see in the lower right-hand corner, we've got the ferrule, the little ceramic ferrule on the stud, and then just to the left of it is a stud that has had the ferrule cleaned off. And then in the lower left-hand corner, we got this gentleman in orange, and he's making a bunch of stud welds. So once you get these things lined up, a guy can just, put these in, and it's just, you can just rattle these off. You can make a significant amount of production with very little time. Whereas if you had to stick weld these or use shielded metal arc welding to weld all these down, you would be there for a very significant amount of time. Clause 8, strengthening and repair of existing structures. This is the clause where it tells you, strengthening and repairing of an existing structure shall consist of modifications to meet design requirements specified by the engineer. The engineer shall prepare a comprehensive plan for the work. Such plans shall include, but are not limited to, design, workmanship, inspection, and documentation. Except as modified in this section, all provisions of this code shall apply equally to the strengthening and repairing of existing structures, including heat straightening of distorted members. I haven't dealt with this one very much either. I've kind of assisted a structural engineer or two, helping them, guide them through this, and letting them know what is realistic and what is not realistic in regards to welding and maybe a direction we should go. But if you're fabricating something, this isn't something you unilaterally go into. The engineer needs to be involved. The engineer shall prepare. Shall is one of those words that's like he shall. The engineer shall prepare. They're the ones that are in charge of getting you lined out to do the work. And if you are the engineer, well, this is the one you need to follow. If you've got some structure that needs to be torn down or strengthened or repaired, or you've got issues, you go to Clause 8, and this will help guide you through it. Clause 9, tubular structures. If you look at the older versions of the code, all this material that covered tubular structures is covered in other clauses of the code. But I think in the latest rewrite in 2015, they just said, all right, we're going to get tubular structures and we're going to put it in its own little mini code. Kind of like like I said, stud welding was its own little mini code. Tubular structures is its own little universe. So then they put tubular structures into its own little mini code in Clause 9. And this is my take on it. This is my version of events. I could be totally off in the weeds in this regard, but this is my take on it. This is my opinion. So this clause supplements clauses 1 through 8. The specific requirements of Clause 9 apply only to tubular connections. Tubular connections. It lines it out there. Design of tubular connections, pre-qualification of welding procedure specification qualification, performance qualification, fabrication, and inspection. If you look at it, all of those things are covered in the rest of the code, the previous 8 clauses. Here you've got a duplication of those previous 6 clauses, and outside of stud and welding and repair, the previous 6 clauses, they're covered here. This is a supplement that just deals with tubular. So if you get into a situation where you're qualifying a tubular weld, this is the WPS you need to go to, or this is the section you need to go to write WPSs, PQRs, and everything like that. So, like I said, Clause 9 is pretty much its own little mini code in regards to tubular connections. Okay, summary. What have we covered? We covered Clause 1 was general requirements. Kind of sets the table, lays out the ground rules for AWS D1.1. Clause 2 is design of welded connections. That's where the engineers go into to talk about and figure out the criteria and the information they do to do calculations in regards to welded connections. Clause 3 is pre-qualification of welding procedure specifications. That's if we use a known material that's listed in clause 3, and we weld it with a filler material in clause 3 with a welding process that is pre-approved. We can't use gas tungsten arc welding, we can't use electrogas welding, we can't use gas metal arc welding short circuit and still be in the good graces of clause number 3. Clause number 4 is everything that we can't do in clause 3, pre-qualified WPSs. If we want to use electroslag or we want to use a filler material that is outside the boundaries of clause 3, it kicks us into clause 4. Clause 4 is also qualification of welders, welder qualification. Clause 5 is the rules for fabrication. You know, it tells us everything we need to know about fabrication, putting the parts together, what we can and can't do, what needs to be done. Clause 6 is inspection. Visual, non-destructive, ultrasonic, that's all in clause 6. Stud welding, that's a little miniature code in and of itself. It doesn't tie back to much in the other previous 6 clauses, but stud welding is integral to structural steel fabrication, so it gets its own little mini code inside of clause number 7. Clause number 8 is strengthening and repair of existing structures. This tells engineers what they need to do to put together a plan on strengthening or repairing existing structures. This is pretty much engineering hit lifting type stuff. This is where they're going to do their work if there's something, an older structure that needs some tender loving care. They're going to put together the plan, and this is the rules for putting together that plan. Tubular structures, this is a recent addition. It wasn't in the previous codes as far as I know. I think the welding code people said, all right, we'll take tubular structures and we'll take that out and put it into its own little mini code like we did stud welding. But what is in clause 9 in tubular structures, it feathers into or blends into or is supplemental to clauses 1 through 6. It doesn't, tubular structures doesn't really go into stud welding and strengthening of repairing structures. But I think it just makes it, when they split out tubular structures, it made it a lot cleaner code because they just took that out of there. And if you need to do anything with tubular structures, you just go to clause 9. You're not digging through one of the other clauses in the code. I hope this sums it up without making it too damn confusing for everybody out there. Any questions, comments? You guys know how to get a hold of me. There's my website. My name's Gary Pace. I'm a CWI and a professional engineer. My focus is on welding. So if you got any questions, I know some of you have sent me texts or emails and asked questions. So feel free to do that. Sometimes I might not get back to you very quickly, but I will get back to you. All right. Take care. Have a nice day.